PR.7 Operations with Exponents. Southwestern College, Professor Maria Olivas. PR.7 Operations with Exponents. This is a prerequisite to the power rule for derivatives. Our next topic of differentiation will be something called the power rule. In order to apply this new differentiation rule, we will need to be fluent in operations with exponents, including how to rewrite exponential expressions in a variety of ways. In this supplement, we will review the following: properties and operations with exponents, fractional exponents, and radicals. 1. Properties and operations with exponents. Given x and y are not equal to 0, the following properties hold true. 1. X raised to the 0 power is going to be equal to 1. 2. X raised to the negative b power is equal to 1 over x raised to the b power. And x over y, all within parentheses, raised to the negative b power is equal to y over x, all within parentheses, raised to the b power. And this is also equal to y raised to the b power over x raised to the b power. 3. Multiplying expressions with like bases. If you have x raised to the m power times x raised to the n power, this will be equal to x raised to the m plus n power. 4. Dividing expressions with like bases. If you have x raised to the m power divided by x raised to the n power, this is equal to x raised to the m minus n power. 5. Removing parentheses. Raising a power to a power. X raised to the m power raised to the nth power is equal to x raised to the m times n power. And if you have x times y inside parentheses all raised to the nth power, then we can have x raised to the nth power times y raised to the nth power. Examples. Evaluate each of the following. No calculator. Number 1, we have 7 raised to the 0 power. So anything raised to the 0 power is going to give us 1, except 0 to the 0 power. So here we're fine because 7 is not equal to 0. So 7 raised to the 0 power is equal to 1. And I'm going to box in that 1. Number 2, 4 raised to the negative 2 power. When you have a negative exponent, we're going to have to rewrite this. So I'm going to write 4 raised to the negative 2 power is equal to 1 over 4 raised to the second. And if we simplify this, this will give us 1 over 16. And I'm going to box that answer in. Number 3, we have negative 2/3 all inside of a set of parentheses raised to the negative 3 power. So first thing, I'm going to rewrite this as negative 3/2 inside parentheses raised to the positive 3 power. And now this is going to be equal to negative 3/2 times negative 3/2 times negative 3/2. And if we simplify this out, we will end up with negative 27 over 8. And I'm going to go ahead and box that answer in. Examples. Use your properties of exponents to simplify each of the following. 4. So inside parentheses we have 2a raised to the 5th, b raised to the 4th, and then this is all inside parentheses, it's being raised to the 3rd power, times 6ab. First thing I'm going to do is I'm going to use my power rule for exponents. So I'm going to rewrite this as 2 raised to the 3rd, a raised to the 15th power, b raised to the 12th power, times 6ab. And then if I simplify the 2 to the 3rd, that gives me 8, a to the 15th, b to the 12th, times 6ab. And then if I multiply 8 times 6, and then I've got the same bases here, I can multiply a to the 15th times a, and that will be multiplied with b to the 12th times b. I can use my product rule for exponents. I wrote ones for the a and b, the ones that didn't have exponents on them. So this will give me 48 a raised to the 15 plus 1 power and b raised to the 12 plus 1 power. So it'll be 48 a to the 16th power, b to the 13th power, and I'm going to box that in. I'm going to go ahead and draw a vertical line segment to separate the work from problem 4 and problem 5. Problem number 5, inside parentheses we have 2 over 3x to the 5th power, and that's all inside parentheses, and it's being raised to the negative 2 power. So then this is going to be the same thing as 3x to the 5th over 2, all within parentheses, raised to the 2nd power. I'm going to write the exponents of 1 on the 3 and the 2, and I'm going to multiply this 2 with all of the exponents that are inside the parentheses. So I drew a circle around the 2 and I drew arrows pointing towards all the exponents. So I'm going to get 3 raised to the 2nd, x raised to the 10th, over 2 raised to the 2nd. If I simplify this, I will get 3 squared is 9. So it'll be 9x to the 10th over 4. I'm going to box that in. Part 2, fractional exponents and roots. A, roots. Recall that we may not take an even numbered root of a negative number. That would be imaginary. So our rule here is going to be the nth root of x raised to the m power is equal to the nth root of x, all within parentheses, raised to the m power, as long as the nth root of x exists. Examples. Evaluate each of the following, no calculator. 6. The cube root of negative 8. I'm going to write negative 8 as factored out. I'm going to write it as negative 2 times negative 2 times negative 2. Since we have 3 of the same factor here, I can take the cube root of negative 8. So the cube root of negative 8 is just going to be equal to negative 2, and I'm going to box that in. 7. The fourth root of 9 squared. So 9 squared is the same thing as 9 times 9. I'm going to draw a factor tree here. And then for each one of these 9s in the factor tree, I'm going to factor into 3 times 3. And then I'm going to cross out the 9s because I factored those out. So the prime factorization of 9 squared is 4 factors of 3. I have drawn a cloud around those 4 factors of 3. So that's what I'm going to take out of the fourth root. This will be equal to just 3, and I will box that in. 8. The cube root of 27 raised to the 4th power. So I notice that 27 is a perfect cube. So I've circled my rule from up above, and I've drawn an arrow pointing to problem number 8. I'm going to rewrite this problem using that rule. I'm going to write the cube root of 27 inside parentheses, and then outside the parentheses, I'm going to write it being raised to the 4th power. 27 has 3 factors of 3 within its prime factorization. So I can go ahead and I can factor that 27 out, draw a cloud around the 3 factors of 3. And that way I know that I can take the cube root. Cube root of 27 is just 3, and then I just raise 3 to the 4th. So 3 raised to the 4th power, that's going to be equal to 81. And I'm going to put a box around that answer. Number 9, the square root of 4/9. I can take the square root of 4, and I can take the square root of 9. The square root of 4 is just going to be equal to 2, and the square root of 9 is just equal to 3, so the answer is 2/3. I'm going to put a box around that answer. B, fractional exponents. Fractional exponents are related to roots in the following way. X raised to the m over n power is equal to the nth root of x raised to the m power, which is equal to the nth root of x inside parentheses, all raised to the m power. I'm going to write that This is equal to x raised to the m over n power, but I'm going to write it so that the exponent looks like you can easily tell vertically what the numerator and denominator is, just because I feel like the notation here is not very clear. Examples, evaluate each of the following. Number 10, we have 27 over 64 inside parentheses, all being raised to the 1/3 power. That means we're taking the cube root of 27 over 64. I'm going to factor out 27 and 64. 27 is made up of 3 factors of 3. That's the prime factorization of 27. So before I do that, let me actually just write it separated. I'm going to write the cube root of 27 in the numerator and then the cube root of 64 in the denominator. Now I'm going to factor this out by using a factor tree. 64 is 4 times 4 times 4. So I drew a cloud around those 3 factors of 4, and I'm going to factor that out and then take the cube root. And now 27 is 3 times 3 times 3. So I drew a cloud around the 3 factors of 3. So if I take the cube root of 27, that's just going to be equal to 3. So the answer here is going to be 3/4. Let's draw a cloud around that. Let's draw a box around that. Number 11. We have 16x raised to the 4th power, all inside parentheses, raised to the 1/2 power. So when we have a 1/2 power, that means a square root. So we're taking the square root of 16x to the 4th. 16 is 4 times 4. And then x to the 4th is x squared times x squared. And I drew little clouds around those 2 factors, so that way I know I can take the square root of each one of those. So the answer is going to be 4x squared, and I drew a box around that. Number 12, we got -8 inside parentheses, and then we have this being raised to the -2/3 power. The first thing I'm going to do is get rid of the negative exponent by writing this as 1 over -8 inside parentheses raised to the 2/3 power. Now I'm going to use that rational exponent to rewrite this as 1 over the cube root of -8, and then I'm going to put parentheses around that whole cube root and raise it to the 2nd power. So this will be 1 over -2 inside parentheses squared, and this will be equal to 1/4. And I'm going to put a box around that. Examples. Use properties of exponents to rewrite each expression in the form ax raised to the b power. This will become very important when we apply the power rule in calculus. So for the first one, number 13, we have 4 over x cubed. I'm going to rewrite this so that the x is in the numerator. So I'm going to have to rewrite it as 4 times x raised to the -3 power. And I'm going to box that in. Number 14 is 4x inside parentheses. 4x is inside the parentheses, and it's being raised to the -3 power. So this means the same thing as 4 raised to the -3 power and x raised to the -3 power. So I'm going to rewrite this as 1 over 4 cubed times x raised to the -3 power. So it'll be 1 over 64 times x raised to the -3 power. And I'm going to box that in. Number 15, 3 over 2 radical x. This is equal to 3/2 times x raised to the -1/2 power. And that's going to be it for that problem. We're going to box that in. Number 16, we got 5 over 3x squared. So I just need to move the x squared to the numerator portion. So I'm just going to have to apply a negative exponent on there to move it upward. So we're going to have 5/3 times x raised to the -2 power. Number 17, -2 times the cube root of x raised to the 4th power. So this is going to be rewritten as -2 x raised to the 4/3 power. And we're going to box that in. Number 18, the square root of x over 3. So I can rewrite this as 1/3 times x raised to the 1/2 power. And I'm going to box that in. Number 19, 5x to the 7th over 3x to the 9th. We can use the quotient rule for exponents here. I can subtract. I need to be careful with the order when I use this rule. So I'm going to write this as 5/3 x raised to the 7 minus 9. So that's going to be 5/3 times x raised to the -2 power. And I'm going to box that in. Number 20, 1 over 5 times the 5th root of x squared. This is equal to 1 over 5 times x raised to the -2/5 power. I'm going to box that in. And lastly, we got 21 is equal to x over 9. So this will be 1/9 times x. And that's it. We'll box that in.